Hi there, Mr. Holcomb here with another lesson in pre-algebra. This is Unit 6, Lesson 2, Session 1, Exploring Reflections. Okay, so learning targets. I can reflect figures on the coordinate plane. I can use coordinate notation to describe a reflection and identify the line of reflection. I can use repeated reasoning to explain why a reflected figure preserves the size and shape of the original. Okay, quick example, give me 5. Use all the numbers in any order with any operation to equal the target number in red. So we want to get an 8. So I'm just going to do a couple basics. If I took a 5 and I said -1 times 5 plus -3, I'm using this and this, and -5 times 5 is 5 plus a -3, which means -3. So we will get rid of that double sign. And that so far that is 2, and we want 8. So I actually would want to change this to minus a -3 to get it to work, because minus a negative would be plus, and then we'd get 8. So sometimes if you just start and then make adjustments along the way, you will get what your outcome should be, which is 8. Okay, so if I try that one more time. Okay. So if I want to use 9 somehow, how do I get from 9 to 8 with these numbers? Um, let's see, 9. I got it. Okay. Plus -4. Okay. Minus a -3. So we take 9 plus a -4 minus a -3. So whenever we have double signs, we switch those. Plus a -4 is -4, and minus a -3 is +3. And then we work left to right. 9 minus 4 is 5, plus 3 is 8. Okay, so I could do more and more and more, but you get the idea. There's a couple examples there, and we will move on to the lesson. So here's a picture of I don't know, that looks kind of like an egret, a great egret. So what do I notice? I notice a sunset, I notice water, but in the context of this lesson, okay, right here is the reflection of the bird in the water. So that's what we should be noticing. And what would we wonder? Well, we would wonder if the reflection is the same size as the bird, and is everything going to line up with what's on the other side? Okay. So we're going to start off by rearranging furniture. It says Danilo bought a new couch and 2 chairs. So here's the couch here. Here are the 2 chairs for his living room, and cannot decide how to arrange the furniture. He decides to draw the layout of his living room as shown. First, he put the couch to the right of the fireplace. Okay, here's the fireplace here. So first he put the couch to the right of the fireplace when you're facing the fireplace, and the chairs to the left. He wants to try flipping the couch and the chairs. Where would the couch and chairs be positioned if they were flipped? Okay. So if this is flipped, for starters, let me get my pen. If this were flipped, get that stain off the rug. If this was flipped, you see this right here, the seat cushion? This is a seat cushion. If I flip that over, it would end up over here. Okay, but then the couch right here would also be flipped. So if I just draw this showing that, okay, and then I'm going to reflect all of this. So what I'm going to do, this will not reflect. Okay, so I can't do that. Let's get rid of this drawing. So if I pick all of this and rotate it, it's not a rotation though, it's a flip. So if we flipped it over an imaginary line that is drawn right here, the couch would end up here facing this way, and the chairs would end up over where the couch is facing the couch. Okay. Danilo wants to try flipping it. Why might he do this? Well, maybe he wants 3 people to the right of the doorway and only 2 behind, or the other way around if he's going to flip it. Who knows? Maybe he's into feng shui, if you know what that is. If you don't, Google it. So anyhow, there's also a desk over here with a chair. So maybe he just didn't want the couch over that far. Maybe he could put the chairs closer to the fireplace over here because they're 2 different separate pieces of furniture. Who knows? Okay. What do you notice about the distance between the couch and the vertical line at each location? Okay. Well, they're the same. So if this is X in the other direction, which would make it negative, but the absolute values would be equal. So Danilo flips the chairs. What do you notice about the distance? We just did that. Similar to the couch, the chairs' distances from the vertical line at their original locations are the same as the distances from the vertical line in their new locations. Okay, so it asks what you notice about the distance between the chairs and the vertical lines at each location, and it's going to be the same, X and negative X, okay, whatever that distance is. What do you notice about the size and shape of the couch and chairs from before they were reflected? Well, if you move a couch, if you slide a couch across the floor and put it in a different location, the couch is still a couch of the same dimensions. It doesn't get bigger, it doesn't get smaller, it's just in a different location. So a reflection flips a figure over a line of reflection. So this dashed line down the middle of the room is called a line of reflection. So they highlighted that right here. I will highlight it here. This is an example of a rigid motion because the shape and size of the reflected figure are the same as the starting figure. Okay, so let's see. Where would the couch and chairs be positioned if they were flipped? We already answered that, so let's move on. This is all repetition. Okay, they'd be placed on opposite sides of the line of reflection. Their distances from the line have not changed. The size and shape have not changed. Okay, what's another tool that would be helpful in approaching this problem? Well, we could put a dot in the center of the floor and do a rotation of the furniture, but that's another lesson altogether. So what do you know about the reflections in your everyday life? Okay, I'm going to leave that to you because it's an open-ended question. If I were to answer, I will say it verbally, but I won't write it. Well, you look in the mirror in the morning to, I don't comb my hair, but if I did, I'd look in the mirror to do it. And my right ear would be the left ear of my reflection, and my left ear would be the right ear of my reflection. Okay? B, what would the room look like if he used a line that splits the room in half from left to right of the original drawing to flip the furniture? Okay, so this is what they're saying now. Let me get a line and I'll make it dashed. And now they're saying to do it here. Okay. So what would the room look like if you used the line to split the room in half from left to right? Is that what they're saying? In the original drawing, to flip the furniture. Oh, no, it isn't. Flipping the room from left to right is the same orientation. Let me just move this way. So what would the room look like? Well, for starters, the couch would be here. The chairs would be over here. This table and chair would be here. And this looks like a TV maybe on the wall. That would be over here instead. And oh, by the way, this door, and whatever this is would be here, and the door would open this way. Okay, so if everything were flipped, the door would open in the opposite direction and all the furniture would be on the other side of the room to where it is now. Okay, that's the end of session 1. Hi there, Mr. Holcomb here with another lesson in pre-algebra. This is session 2 of lesson 2 from unit 6. So what do you notice? What do you wonder? Well, I noticed 2 triangles, and I noticed that they're on opposite sides of the x-axis, and I noticed that they're a reflection. What do I wonder? Oh, I don't know. Good question. What do I wonder? I wonder if that's where they got this song name. I don't know. You guys don't know what I'm talking about. It's a song. But anyway, let's move on. Triangles on the coordinate plane. The vertices for triangle ABC are 1, 5. So that's A over 1 up 5. B is at 1, 1. And C is at over 4 up 1, 4, 1. The triangle will be reflected across the x-axis. So I'm going to highlight that with a red line. So we are reflecting across this x-axis. When you reflect across anything, whatever line, the distance the point is on one side is equal to the distance it's going to be on the other. And that's how we're going to do this. So it says, where will triangle A prime, B prime, C prime be after being reflected? Okay, so let's take a look. What quadrants will the triangle be in after it's reflected across the x-axis? So let me go back and get that red line I created. And copy it, paste it, put it where it was. Okay, so let's talk about quadrant names. The original, the pre-image is in quadrant 1. Quadrant 2 is over here. If I'm going to move this far and then move it that far again, B prime is going to be right here. And everything's going to get flipped over this red line. I'm not in 2 or 3. I will be in quadrant 4. What quadrant will the triangle be in? Q4. Quadrant 4. Okay. So after reflecting point A, which is 1, 5, which is 1, 2, 3, 4, 5 away from the x-axis, 1, 2, 3, 4, 5 away from the x-axis on the other side, that will be A. And I don't know why they didn't put it, but that's A prime. So after reflecting point A, 1, 5 across the x-axis, point A prime will be at 1, negative 5. Okay, so there's going to be a pattern here we're going to look for. So I'm going to highlight it now. What was our x value for our pre-image? 1. What was our x value for our image, A prime? 1. So when reflecting across the x-axis, x didn't change. What was the y value in the original pre-image A? 5. What was the y value of the image y prime or A prime? Well, negative 5. So reflecting across the x-axis will give us a rule. I might as well just tell it now. The rule is going to be the point original is going to become the new x comma negative y. So x is the same, y changes signs, 5 to negative 5. After reflecting B, 1, 1 across the x-axis, point B prime will be at 1, negative 1. So again, the x stayed the same, the y became negative. Okay, so without letting the cat out of the bag, where do you think 4, 1 is going to end up? X doesn't change, y negates. So it's going to be 4, negative 1. Okay. So what happens to a point when it's reflected across the x-axis? Well, when you reflect it across the x-axis, I've already said this, the x does not change, the x value. We still move to the right the same distance or left if it's on the left side of the y-axis, okay? But the y value gets negated. So it's the opposite. So if it was -2, a -2 is +2. Okay, they can go either direction. Okay, so how do the distances between the points of the pre-image and the x-axis compare? Okay, well, B is 1 away, B prime is 1 away, C is 1 away from the x-axis, C prime is 1 away, A is 5 away, A prime is 5 away the other direction. Okay. So the vertices of triangle ABC are 1, 5, 1, 1, and 4, 1. The triangle will be reflected across the x-axis. Where will they be after being reflected? Okay, we've already kind of gone over this multiple times. So this is B prime. This would be C prime. They're both 1 away from the x-axis, and A prime would be way down here. And there it is there. So after being reflected, the vertices of triangle A prime, B prime, C prime are 1, -5, 1, -1, and 4, -1. So x, -y, x, -y, x, -y. What statement can you make about the x coordinate and y coordinate for the triangle A prime, B prime, C prime when a triangle ABC is reflected across the x-axis? Okay, what can you make about the x and y coordinate? The x coordinate stays the same. And the y coordinate changes sign. Okay. What would be the coordinates of triangle A prime, B prime, C prime if triangle ABC reflected over the y-axis? Well, here's the y-axis. We're going to go left and then left another. And A would be over 1, then over 1 more. So A is over 1 up 5. But A prime now would be left 1 up 5. B, which is at 1, 1, would become B prime, and its location is -1, 1. So look what's happening. The x is getting negated, the y is staying the same. So I'll do that with C. C is over 1, 2, 3, 4, up 1. So C is at the point 4, comma 1. So C prime is going to be x times -1, or negating x, which is -4, and the y will stay the same. So it's going to end up at -4, 1, 2, 3, 4, 1 right here. So then when I draw this, our triangle's right there. Okay. So let's summarize. A reflection reflects or flips a figure over a line called the line of reflection. Each point of the image is the same distance from the line of reflection and as each point of the pre-image. Same distance from the line of reflection. Okay, 3, 3, 3, 3, 1, 1. Egg decorating. Pysanky is the ancient Ukrainian art of egg decorating. Pysanky. Many artists use reflections to create their design. What is a design that has symmetry over the X and Y axis? I'm going to leave that open for class discussion. I'll move on. And that brings us to the end of lesson 2. Thanks for watching. Have a great day.